Alright, let's look at the homework 7, problem number 18. Alright, so first question, we have a function here, and the domain is, this is simply a polynomial function, so domain is all real numbers. So it's going to go from negative infinity to positive infinity. Alright, so let's check the answer. Alright, we got that. Alright, what is the y-intercept? Alright, so y-intercept is easy to find because all you have to do is plug in 0. Alright, but if you plug in 0 for x, alright, if you plug in 0, you're going to get 0 too. So you have y equals 0 is the y-intercept. Alright, so we got that. Alright, what are the x-intercept? We set this guy equal to 0. So x equals 0 and x equals 2. So it's going to be 0 and 2. Alright, so check the answer. Alright, we got that. Alright, and the next one, what is the local maximum or local maximum? Or let's find out. Alright, so we're going to take the derivative. Alright, first derivative. F prime of x is equal to, I'm going to leave 2 alone, so here, this 2, so this is just a constant multiple, so 2 here, then I'm going to use the product rule, because this is the first guy, this is the second guy there, so derivative of x is 1 times, the second guy is x minus 2 cubed plus first guy times derivative of the second guy is 3 quantity x minus 2 squared. Alright, so we got that. Alright, then I'm going to pull out some common factors. Alright, so you have quantity x minus 2 squared. There are actually 3 of them, so I'll just circle this so that I know that there's another x plus 2 there. So we have x minus 2 squared, right? And what's left is another x minus 2 from the first term, so that will take care of this guy. And then we still have 3x, so we're going to have plus 3x, right? Then this is going to simplify to, let's say, so you have 4x minus 2, so which means that both of them are even numbers, so we can pull out the 2 here. So 2 was already originally there, so it's a 4 x minus 2 squared, and you pull out 2, so 2x minus 1, right? So if you set that equal to 0, we can find the critical numbers, right? So x equals 2 is one of them. Let's see. X equals 2 is one of them. I set 2x minus 1 equal to 0, so you have 1/2, right, is the another one, right? So let's try to see if we can see if you have a local maximum or local minimum, right? So I'm going to do a number line. Alright, x. Alright, so I'm going to put 1/2 and 2. Alright, then we're just going to test the sign. So anything less than 1/2, so let's try 0. Alright, if you plug in 0, so here's the derivative. If you plug in 0, that part is positive. Alright, so 0 is 2 times 0 minus 1, so that's negative. So the whole thing is going to be negative. Right? If you plug in, say, 1, so anything between 1/2 and 2, so if you plug in 1, so that's positive, 2 minus 1 is positive, everyone's positive, so this is going to be positive there. And how about anything bigger than 2, so like a 3, positive, positive, everyone's positive. Right? So you have decreasing, so the graph of the function f is going to look like this. Derivatives is it's negative, so it's a decreasing here. and after that it's increasing here and then increasing there, right? So we can see that there is actually no local maximum, right? So here there is no local maximum, right? Check that. All right, we got that. All right, and local minimum, right? So we can see that the local minimum happens here. So decreasing turning into increasing. So you have a local minimum happens at x equals 1/2. All right, so let's right, so local minimum at x equals 1/2. All right, check the answer. All right, we got that. All right, and we want to find inflection points. All right, so we need to take another derivative. All right, so if you take the derivative, so I'm going to take the derivative of this guy right here. It's already factored out nicely. All right, so second derivative, f double prime of x is equal to, so 4 is just a pulled out, right? So it's just a constant, and I'm going to think of this as the first guy, and this is the second guy. So I'm going to use the product rule again. All right, derivative of the first guy is 2 and quantity x minus 2 to the first power, and derivative in size is 1. So just that times the second, which is 2x minus 1 plus, all right, first guy is x minus 2 squared. Derivative of second guy is 2. Right? So common factor, first you have a 2 here and 2 there. Pull it out. So 4 was already there, so 4 times 2 is 8. And we have x minus 2, here there are actually 2 of them. So we have quantity x minus 2 is pulled out. Alright, so what's left is 2x minus 1 from the first term. And then we have x minus 2 from the second term. So plus x minus 2. Right, so you can see that they have 8x minus 2, and that will be 3x minus 3. Right, so we can pull 3 out. So 3 times 8 is 24, x minus 2, and x minus 1. So we set the second derivative equal to 0 so that we can find the possible location of inflection point. So you have x equals 2 and 1. I'm going to put 1 first, 1 and 2. All right. So let's see if we can, we see inflection points there. So here, we just have to make sure that there's a concavity change. All right. So we have 1 and 2. All right. So we can look at anything smaller than 1. So let's try 0. If you put 0 there and put 0 there, negative 2, negative times negative. So this is going to be positive. Anything between 1 and negative, so how about the 1.5? All right, second derivative. So 1.5, that's negative. 1.5 here positive, so it's going to be negative there. All right. After 2, so we can probably try 3 or something like that. 3 minus 2 is positive, 3 minus 1 is positive, so everyone's positive. Alright, so you can see that the original function f is here and concave upward, after that concave downward, after that concave upward. So there is a concavity change here, so this is going to be an inflection point at 1. And the inflection point at 2 as well. Alright, so let's type it in. Inflection points are at the 1, 2. Alright, check the answer. We got that. And what interval f is increasing or decreasing? Right, so I'm going to have to go back here. Alright, so it's decreasing on the interval before 1/2. After that, it's increasing. So here, increasing on, right? So starting from 1/2 to infinity, and decreasing on the negative infinity to 1/2. Alright, so let's check the answer. Alright, we got that. Alright, so f is concave upward. Let's see, what was it? Alright, concave upward before 1 and after 2. Alright, so let's type it in. Concave upward before 1, so it's going to be negative infinity to 1. And after 1, so after 2, so 2 to infinity. And the concave downward between 1 and 2. Alright, so let's check the answer. We got that. Alright, then we need to find the correct picture. Alright, so let's see. It's decreasing before 1/2 and increasing after. So number A isn't the correct picture, and C isn't the correct picture. D isn't the correct picture. The only one does the decreasing and increasing here is going to be B. Alright, let's double check. Alright, decreasing, increasing. So this is the correct picture. Alright, so let's check the answer. Alright, we got that. Alright, that's it. I hope that this was clear.